Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, so 4 hours. This is stuff that, you're like, when are we going to get there, Mom? When are we going to get there? Well, do the math, right? If you're going 50 miles per hour, like maybe there's traffic, and so sometimes you're going 60, sometimes you slow down to 40 or something. So you're averaging like 50 miles per hour, and you travel for 4 hours, then you get 200 miles. So if your destination is 200 miles away and you're going 50 miles per hour, then okay, so let's see how many 50 miles per hour are in 200 miles for. So you can do that. So this is familiar ground. But if you're confused at all, you can use unit multipliers. We've talked about unit multipliers, right? Okay, good. So if we want to say 4 hours at 40 miles per hour, I want to know how many, so we want to convert hours to miles. Okay, so if I go 4 hours, write the first number as a fraction. That's first step to unit multipliers. And then we want to do something that will cancel the hours. So this is 50 miles per 1 hour, right? So then those cancel, and you're left with 4 times 50, which is 200 miles. Okay, so that's using unit multipliers. For something like this, it just seems silly, right, to use unit multipliers. I mean, you could just do the math, figure it out. So you either are going to multiply or divide by something. If you divide by 4 divided by 50 or 50 divided by 4, that's not going to tell you much, okay? But let's see here. Let's say we're going to go 300 miles. How long does it take? 300 miles equals how many hours at going 50 miles per hour? Can you do that in your head? Yarrow?
Is it 5?
Not 5. Do you know?
6.
6, right? But if you can't figure it out in your head, do unit multipliers. 300 miles. And then what unit multiplier am I going to do? Am I going to do this one? No, because it won't cancel the miles. We want to cancel the miles. So instead of saying 50 miles per hour, you can say 1 hour per 50 miles. There's nothing wrong with that. Okay? If a police officer asks you how fast you were going, you can say, I was going one hour per 50 miles. There's nothing wrong with that. He'll think you're a moron and might give you a ticket for being dumb. But you can say that, right? So now what kind of math is this? 300 hours divided by 50. Well, that's just 6 hours. Okay? So unit multipliers don't just work with length and stuff like that. You can use them for pretty much any rate or ratio. All right, let's try it with something else. Let's try another rate here. Let's see. Let's say there are 5 chairs in every row in a theater or an auditorium, okay? So can you visualize this auditorium? 5 chairs. Yeah, it's a small auditorium, but maybe it's like COVID friendly, so they're like spaced out or whatever. 5 chairs in every row, okay? How many are in 6 rows? Well, I think you guys can figure this out without using unit multipliers.
5 times 6.
Right, you're either going to multiply or divide, but let's use unit multipliers. So 5 chairs. Oh wait, that's our rate. So how many in 6 rows? So 6 rows equals how many chairs? That's what we want to figure out. 60. So times, okay, well, let's see. The rows go on the bottom because they have to cancel. Chairs go there. So 1 row is 5 chairs. All right, so now we're just multiplying. 6 times, so these cancel out, and we get 30 chairs. Okay? So sometimes when it's, here's what happens when you're with your brains. Sometimes there's like fractions or decimals. And what fractions and decimals do, even if you're good at fractions and decimals, they just mess with your head. Okay? They make everything more complicated, unfortunately. Okay? I know that if you say 5 times what equals 20, well, then you know it's 4. But if I say 5/3 times what equals 3.5. Then you're like, wait, are we still dividing? Yeah, we're still dividing because you're still missing that part of a multiplication problem, but fractions just mess you up. Okay? All right, let's try a couple more examples, then we'll move on to the next lesson. You guys feel okay with this so far?
Yes.
So let's say we've got 8 ounces is 40 cents. We don't know what 8 ounces of, maybe a can of beans or something, I don't know. Okay, so I want to write this rate. So how do I write this rate? So I'm going to write a rate like this. Okay, so there's 2 ways to write it. There's actually 4 ways. I could say 8 ounces per 40 cents, or what else could I say? Hunter?
40 cents per 8 ounces.
40 cents per 8 ounces. And there's another way. Anyone else know another way? If you were trying to do this math, and we don't have a math problem yet, but what would you do first if it was you?
Stare at it for a long time.
Okay, that's a good strategy. Yes.
Figure out the answer.
Okay, figure out the answer. Well, we need a problem first. So let's just do that. Let's say 32 ounces. How much does 32 ounces cost? Can you guys do that in your head?
No.
Do you know what it is? What is it?
$1.60.
$1.60? Let's see if you're right. So I'm going to use unit multipliers because that's what we're talking about. 32 ounces over 1. Okay, which one of these is going to go next? The first one or the second one?
First one. Nope, second one.
Why?
Because the ounces need to be on the
You want the ounces diagonal so you can cancel it out. Here's another way to think about it. The top is what you're trying to get to. The bottom is what you're trying to go away from. Okay? You want to bury the past. Bury the past. So the ounces need to go on the bottom so you can cross cancel. And then I'm left with this math here. Let's see, I could probably cross reduce because that's what the cool kids are doing. 1 and 4. So then I get 160 cents, which is $1.60. Good job. All right. Anyone do it another way? In your head? What did you do it? You did it different? What did you do?
Yeah. I knew that like 8 ounces would be 40 cents, so I figured out how many times I have to multiply 8 to get to 32, and then which was 4. So I multiplied 40 by 4. I removed the 0 and then I added the 0 in the end.
Good. So this is kind of what we did here. Look. So we figured out how many 8s were in 32. So 1 and 4, we figured out how many times 8 goes into 32. Then we multiplied by 4t, which is 4 times 4, and then another t, which is a 10, so I add a 0. Okay? There's another way to do this, guys. If 8 ounces is 40 cents, what's 1 ounce?
5 cents.
5 cents. Okay?
Oh.
You could have done it that way. 5 cents or 5 cents per ounce. This is like the unit price. Do you remember talking about the unit price? If 8 ounces is 40 cents, that seems overly complicated. Why can't you just say 1 ounce or 5 cents? Well, if it's like a can of beans, then sometimes the price changes when you go down to 1 ounce. It's more expensive or something.
Why?
Okay? But if you can calculate the unit price like that, then that makes it easier. Oh, 32 ounces. Well, it's 5 cents per ounce. 32 times 5, 160 cents. Okay? So you don't have to use unit multipliers. If you got a method that works every time, great, do it. But eventually, especially in science, you're gonna need to know how to do unit multipliers. It's gonna make your science so much easier. Okay? And science is difficult enough, so make it easier. All right, I'm going to move on to 54 unless there's questions. You guys have questions? Lesson 53? Okay, all right, so I'm erasing. Okay, so this is where we start to apply a little bit more ratios to our life. So this is ratio word problems. So I think, did we talk about the ratio box? So a ratio box is just tic-tac-toe, okay? But don't put X's and O's in there. I know it's tempting. You just want to start playing, but don't. This is called the ratio box, and let me tell you what it's about. So I'm going to give you an example. The ratio of parrots to macaws, I guess that's another type of weird bird, is 5 to 7. Okay, so this is just a little chart. This tic-tac-toe box is a little chart. So I'm going to put P here for parrots, M here for macaws. And then this bottom row we're going to talk about later, but for now we don't have to worry about it. Okay? So parrots. So the ratio goes in this first column. What's the ratio of parrots to macaws?
5 to 7.
Does that mean there's 5 parrots and 7 macaws? No. It could be, right? It could also mean there's like 10 parrots and 14 macaws, okay? So 5 to 7 is the ratio. It doesn't mean that there's exactly 5 and exactly 7, okay? Does that make sense? Mm-hmm. All right, so, but this is not the end of the problem. Here's what it says. Let's say there are 750 parrots. There are 750 parrots. That's a lot of parrots. How many macaws are there? If the ratio has to be 5 to 7, how do you figure out how many macaws there are if there are 750 parrots? Anyone know how to do that? Do you know, Grady?
I would divide 750 by 5.
Okay, and then what?
And then whatever that comes out to be, multiply it by 7.
Good. Okay, so this next column is the actual numbers. So this ratio is just a ratio. That's how the numbers compare, but this is where you put the actual number. Let's see, parrots, 750 goes there. So do you see what I see? I see a proportion. So I see this guy. Boom equals boom. You see those two fractions? Okay, now, do you remember the way there's 2 different ways that you guys know of to find this missing number. And Grady just said, well, whatever you do to the top, you do to the bottom. So let's see, what times 5 is 750? That's 150. So 7 times 150 is going to be 1,050. That works. There's another way to figure out that bottom number. Anyone know the other way? You know?
Fish method.
Fish method. That's right. So this takes a little bit more because 750 times 7, ooh, that's a big math problem. But we'll do it. Let's leave the 0 off for now. So 525, add the 0. So 5250, okay? And then we divide by 5, right? So 5250 divided by 5, that's the fish method. Multiply the cross numbers, the diagonal numbers, and then divide by the one that's left over. So that goes in 1 time, 0 times, and then 5 times. Got it. So 1,050. Either way works. This one's a little bit more mathy because you get big numbers, right? But you can do the hard part first. No one likes to divide. I think multiplication is a little bit more the lesser of two evils, I guess. So, but if you get the hard part over first by dividing and then multiply, you can do that. But sometimes this doesn't always go into that. That's okay. Yes. Yep. All right. Does anyone know the missing number in this? Can anyone tell me that? So see how Grady's method doesn't work here? That's okay. Yep, fish method will always work. The equivalent fraction method doesn't always work, but what do you got?
12.
Okay, how'd you get 12?
I multiplied 9 times 8.
Yep, so fish method. So see how 6 doesn't go into 9, right? So that method didn't work there, but the fish method will always work. 72 divided by 6 equals 12. Okay, so this is an example of a ratio word problem. So it'll give you a ratio, and then it'll give you the actual number of one of those categories. Then you have to figure out the other one.
Wait, couldn't you, I don't know, I think it only worked for some problems, but see how 6 does go into 9?
Yeah, it just goes
more
in
than
like
half times? Could I
1.5.
just go 8, 1, yeah.
You could definitely do it that way too. Sometimes that works,
Sometimes.
but if it's like 1 1/3
Yeah,
and you're trying to do it on a calculator, then that's annoying to use.
Yeah.
Yes, Hunter.
I do it a completely different way.
Okay, there is one more way. Well, how do you do it?
I reduce.
Yes, you could reduce that,
And then multiply.
and then you can do this. So 3 times 3 is 9, 4 times 3 is 12. That works too. Usually this happens when one of these is not reduced. Okay, so if you can reduce it first, then yeah, go for it. And then you can use whatever method you want. Okay, let's try one more example and then we'll call it a day, okay? And then you guys can get some Flack attack points. This is example, actually 1, because this was example 0. Okay, let's say the ratio of boys to girls is 5 to 4. If there are 200 girls, how many are boys? Okay, so you can probably do that in your head, but let's do it slowly and make sure we get it right, okay? So try this one on your own. The ratio of boys to girls is 5 to 4. And so when you say a ratio, you have to make sure you stay in the right order. So this is a ratio of boys to girls. So since I mentioned boys first, then the 5 goes with the boys and the 4 goes with the girls. Okay, so got a couple answers so far. Hold on to those. Looks like you did it in your head, which is okay.
Is this like the ratio of boys to girls in like a whole school or just a class?
You know what? In this school, I think there's more girls than boys, so this wouldn't be the right ratio either. Did you just do this, Addie?
Yes, I did.
Okay, Grady, what'd you get?
160 boys.
Okay. Doesn't look like that would be right because the ratio of boys to girls is 5 to 4, not 4 to 5. See what we did there? There's going to be more boys than girls.
Boys to girls.
What'd you get, Hunter?
250.
Okay, anyone else get anything
That's
different?
why I messed it up. I was gonna say like.
Okay, so it's very careful, and that's why it's dangerous to do
The
it in your
little
head.
camera like tripod thing was kind of in the way, so I saw girls first.
Sure,
and then
blame it on the tripod.
I-
Just kidding. Okay, so I'm going to say BG and then 5, 4. So this is my ratio column, remember? And this is my actual number column. So where's the 200 go?
G.
By the G, so it goes here. So now this time I'm missing that top one. So 200 times 5 divided by 4 is 250. Or you can realize, hey, 4 times 50 is 200. So 5 times 50 is 250. Okay, does that make sense? So 250 what? Boys. All right. That's it. I think you guys can handle this. You guys feel okay about this? Okay, awesome.
Black man, give me some math and I'll give you some flack. Black man.